All right, good morning, everyone. Hopefully you can hear me all right. Awesome, thank you. Yeah, so we've got a full agenda for today, which is awesome because I am fighting a cold, so it keeps me from having to talk a lot. We've got some great demos that are set up for today, and I put the link to the working doc in the chat if you want to link out to the things that we're going to be talking about, and also if you want to add in any additional questions or anything like that. Before we jump into the demos, is there anyone that is new to the call and wants to say hi or share what they're working on? All right. Okay. Well, then, Dimitri, would you like to kick things off with the ballerina demo?
Cool. Sounds good. Thanks, April. So I'm Dimitri. If you don't know me, I work for WSO2, and I'm also involved in the Ballerina project. And I actually have a couple of my teammates here on the call, Kason and Lakmal. And Kason has been working on the Istio integration, and Lakmal did some work on our Kubernetes integration. So I'll do a quick kind of intro demo to Ballerina, like maybe spend 5 minutes for those who haven't used Ballerina or seen Ballerina before. And then I'll pass control to Kason, who will show what we have so far with Istio and what we plan to do. And then I think he also wanted to get some advice on some of the design decisions that we are discussing. So let me share screen. Cool. So hopefully you should be able to see my screen now. So Ballerina it's a programming language that has been designed for microservices, and so it has a lot of native functionality for things like type safety and distributed transactions and APIs and so on. So I'll just do a quick kind of hello world service just to give you a feeling of what it looks like. And then I'll deploy it in Kubernetes, and then Kasun will take it from here and do the Istio part. So since it's a hello world service, and I'll just use HTTP, we have support for other protocols like WebSockets, gRPC, and so on. I'll do a service, and I'll do just a simple, again, HTTP service that would do a hello world thing. So I'll call it hello. We'll add the resource. We'll call the resource hi. And then if I want to just send some HTTP response, I'll create the response object. I'll set some payload to say hello world. And then I will just use the caller endpoint that got passed, so that's whoever called me. And I'll use a remote call for it to send the response back. So I'll say respond. So that's sort of the simple, and it actually can give me some output, but I'll just ignore it. So that's sort of your simplest kind of hello world thing. And obviously, if I want to bind it to a port, then I can create an endpoint, bind to some port, whatever, 9090, and then bind my endpoint, my service to that endpoint. So that's sort of the simplest hello world thing. And then if I want, I can customize it a little further and use annotations for that. So for example, I want to do to say that my service should not be listening to hello path, but it should have some like a different base path. Or I can customize my resource and say that for the resource, again, if I want, I can change path. I can change methods, for example, to post. I can then do something fancy, like I can use that request to actually extract something. So I can say that if I want to get like a string from the request, then I can do that. I can say request get text payload. And it's a union type that it returns. It can return a string or an error. I can do a match and figure out what I do in each case. So I can just use the check keyword, which would propagate the error if the error is there, or give me the payload if it's not. So that's sort of the simplest kind of hello world example that would actually be slightly customized, and let me just run it quickly. Well, but that's like that would be like my post service, for example, that would actually get some input, produce some output, and if I want to invoke it, I would just call into it. Let's see. So I did a post. I'll pass the Istio working group localhost. Right, and if I so that's sort of the simple way to do things. And the cool thing is that so it's a full language. It gets compiled and run. But if I want, I can use some annotations. And in that case, I would compile it not to an executable, but say to my to Kubernetes artifacts. So, for example, right now, if I do ls, I only have that bell file. But if I add Kubernetes functionality, Kubernetes, I can, and I'll just copy and paste from my sample, so you don't have to watch me type in. I can say that I want to change that. I want for that listener to generate an output service, and I want for that service to add some Kubernetes functionality as well. So I could add a config map. I could set some ingress or do some scaling parameters, etc. I'll just do a deployment, and again, I'll copy and paste. And now if I do my Ballerina build, you will see that instead of just creating a run executable, it will go and use these annotations to generate Kubernetes artifacts. So it would generate the service definition, and it would generate me the Docker image and the deployment definition. And then I would be able to just, here it is, then I'll come in. I will be able just to do kube control and apply them. So now if I do tree, you can see that instead of just generating me the executable, it generated the whole YAML structure. So I can do kube control. Oops. I'm not logged into Kubernetes. Anyway, so if I were, it would have just applied them. And so basically that's sort of the feel of what Ballerina is by itself. And there's obviously a lot more to it. And if you go to the website, you can see all the examples of lots of things that it can do. It has all the, obviously, concurrency functionality with the workers and forks and joins. It knows data types, different formats, and so on and so forth. But since it is an Istio working group, I think I'll stop sharing, and I'll let Carson take over and talk specifically about the Istio integration that we have, and what we have right now, and what we are working on. So Carson, can you take over the control?
Yes, thanks, Dimitri. Okay, so let me share my screen. Yeah, hope you can see my screen, right?
Yes.
Okay. So as part of the Istio integration with Ballerina, what we have done was, so Ballerina is a programming language, and we develop services with Ballerina. And so now we need to deploy our service inside Istio service mesh. So the deployment looks like this particular diagram. So you have a Ballerina, a time service running, which is just giving the current time, and which is running alongside an envoy proxy, and again managed by Istio control plane. And for the demonstration, I use Grafana for observability purposes. So as Dimitri showed you earlier, we have native support for Kubernetes through annotations, right? You can just put a couple of annotations inside your Ballerina service, and you can generate Kubernetes deployment descriptors. So when it comes to Istio, again, prior to that, so I'm using Istio 0.7 release for this particular demo. I know there are some changes after that, like in the 0.8 release. I'll come back to those changes later. But based on the 0.7 release of Istio, so we had to do like very minimum set of changes, like putting Istio ingress class, and then one of the properties, like you need to generate every descriptor into a single file, and some of the configuration related to Minikube, which is not specific to Istio. So now I have my service.
Hey, Carson, sorry to interrupt.
Yeah.
Would you mind making your font a little bit bigger?
Yeah, sure.
Thank you very much.
Probably I'll yeah. Maybe this is.
That's awesome. That's great.
Yeah. So ingress class is Istio, and so this is the Kubernetes service definition, which is annotated alongside the inbound listener of Ballerina, and this is my ingress, and so this is the deployment. So we use this parameter to generate a single file. That's the Ballerina specific thing. That's all. This is the Ballerina code, right? So now I have my let me delete the generated Kubernetes stuff. Okay, so you just have to do a Ballerina build of time service, which will generate the Kubernetes artifacts. So it's generating the service deployment and also creates the respective Docker image. And so once we created those artifacts, we need to do some changes because by default the artifact generated by Ballerina, so we are using Fabricate client library to generate these artifacts. There are some manual changes that we have to do. So I have actually included them in our documentation. There are a couple of changes, like removing this host and removing this ingress class stuff, like nginx stuff, and this protocol, changing protocol TCP to name HTTP. So there are like minor manual steps that are involved in this. So once you are done with those changes, you can actually apply. So I already have to save time, I already have a file that we have already created with those changes. So I can just now I can do a Istio control, injecting Istio into this. So for that, I'm using the manual injection and time service. And yeah, all right. Okay. Now I have a Istio injected file created of my Kubernetes deployment. And now I'm deploying my Istio injected Kubernetes artifacts. All right. So you see whether my service is running, and I can basically invoke the service because since we just use a service with base path local time, and so it will generate the current time and respond. So let me try invoking the service. Okay, so it's walking through the ingress. Okay, and I also have installed the Grafana add-ons. We can see on Grafana. So I have installed Prometheus and Grafana add-ons, and I should be able to see the inbound traffic to the mesh as well as the HTTP service, which is Ballerina service. So like it's pretty straightforward changes that we have to do, but what we are planning to do as the next step, as you know, like in the 0.8 release, we don't have ingress, right? And we have the gateway and virtual service configuration in Istio. So we are planning to support this natively through a specific Istio annotation. This is like a rough sketch, a rough idea that we came up with. So what we are going to do is we are going to include virtual service and gateway annotations as part of a Ballerina service. So this is actually a Ballerina service, a coordinate snippet from a Ballerina service annotations. So similar to Kubernetes, we are planning to use these Istio annotations on top of a service so that you won't have to do any manual configuration changes. So basically, whatever the artifact generated from this service can be directly you can basically directly inject Istio configuration into that file, so that we can seamlessly support Istio and we can offer first-class support for Istio. Any thoughts on that?
I have a question. So it seems to me, I'm not very familiar with Ballerina, although I do like the logo. So Ballerina has a bunch of its own reasons you might want to adopt it. Looks like the way it handles data is compelling. Okay. Parallel processing seems interesting. Yeah. But you're also here showing something that is separate, which is in your source files, essentially, you have the ability to auto-generate a bunch of the YAML that other people in other languages are composing by themselves, right? Is that the real benefit here? Is that it's generating the YAML that otherwise I would have to go type myself?
So in the case of Istio and Kubernetes, having those annotations, yeah, it's a productivity benefit. Right. But apart from that, Ballerina has quite a lot of other capabilities, like things like inbuilt support for most of the data types.
Right.
Kafka, gRPC. So it's like first class concept.
Right. Yeah. So that's what I mean. Like, it
Yeah.
has its own things, but here the especially interesting thing to this crowd is the way it's auto generating artifacts that other people are having to compose, which is cool.
Yeah.
Can you do loops and stuff as well?
Yeah.
Yes, it's a full functional language. So it has objects, loops, branching, looping, and so on.
Yeah.
Yeah, thank you very much for the demo. I mean, certainly you can see that other people in other languages might do well to take this same idea that, hey, if everybody in the world is having to compose these YAML files, have them be an output of the build process instead of having everyone just compose them by hand or copy and paste last time they did something, right? And that's cool. That's absolutely a productivity.
That alone made it a big hit at the KubeCon in Copenhagen a couple months ago.
Yeah, definitely.
Okay.
Have the asynchronous open tracing support?
Yes. Open tracing. We have Jaeger and Zipkin support out of the box.
For asynchronous transaction as well, like when you are using Ballerina microservices along with Kafka?
Yes.
Them as well?
You can trace them as well. Yeah. So actually, if you go to like Ballerina guides, Kafka, we have a guide on Kafka, and we actually have guides and which covers entire development life cycle. So observability is also part of that. So tracing is also included.
Thank you both for the demo and the look at the project. I know you mentioned some of the things you're working on for the future. Do you have any asks from the Istio community?
Actually, I raised a couple of questions on Istio Dev, and development community has replied. So I'll get back to you on. So we'll join all the community meetings regularly, and if there are any changes or any requirement, we'll let you know, and I'll communicate through the Istio developer list as well.
Are you in the Istio Slack at all?
I was in that, I guess. Is that a Slack or a Jita?
Well, we use Rocket Chat for
right.
the broader community.
Okay. I'll use that one. Yeah.
Well, we're very excited to have you as part of the Istio community, and then I know you have a conference coming up soon in San Francisco.
Yep, and actually, so April and I, we are working on getting an Istio token to the conference as well. So it's July 18th in San Francisco, and I'll post in the chat window. I'll post a link to the conference and also the coupon code that you can use to register for free if you use that code.
Awesome. Does anybody else have any questions for the Ballerina team? And I have to give a shout out to Zach Jory for making the initial connection with Dimitri and myself. So thank you, Zach, for looking out.
Yeah, glad I could do it. Great demo.
Yeah.
Round of applause for the demo.
Awesome. All right. Well, thank you very much. For next up, we can turn it over to Nick.
Perfect. Hi, guys. Part of the Istio developers group. I'm from the weather company, which is owned by IBM. I gave a talk at KubeCon in Copenhagen about the weather company's use of the Istio and what we're trying to do with it. And in that talk, I gave a demo of Netflix and Visceral. And it took a lot of duct tape and a lot of gluing to make that work. It was very painful, a couple of weeks. And so what I did is I went back because of the amount of interest, and I actually tried to simplify it and make it available to everyone. And so that's kind of what I released about 2 days ago, which I call Vistio. And it's a direct implementation of the Visceral add-on for Istio, so very targeted for Istio. And I'm going to share my screen here. I'll walk through a demo. I think my Medium post is posted in the working doc. So I'm actually going to follow along with that and probably copy paste some commands from there. But I have 2 demos to show in case one of them fails. So I'll share my screen and we'll get started. It's a really cool visualization that Netflix put out, I think, a number of years ago. But it's very, very applicable. So, okay. So the first thing that we probably want to talk about here is I'll bring up my Prometheus window, is that I deployed the Istio book info demo. And so you can see here that all of the reviews, the ratings, and the product page and details applications are already running in my Kubernetes cluster. And this is just, I'm checking the Istio request count rate. So I'm seeing how many requests per second are they currently getting, and they're getting 0. And that's because we have no traffic going to them. And so these are the things we're going to display in our mesh with the live demo. So to get started, because my Prometheus is actually running in a different namespace other than Istio system, I actually explained that I have to modify my example a little bit to just tell this, I'll bring this in here. And so we're going to do the mesh only visualization. And so I actually had to change the Prometheus URL to point to, I'm using the Helm chart deploy for Prometheus. So Prometheus server.monitoring. So if you guys have a Prometheus URL not in Istio system that you didn't deploy with Istio, you might have to come check out the code and modify it a little bit to make this demo work. So to get started, I'm going to do a kubectl apply Istio. We're going to do the mesh only demo in the default namespace. Okay, so that pretty much creates all the entities for you, and I'm going to let that get set up, and I'm going to show you another demo that's using Docker Compose. And why I would use this if you were to use Istio is if you want to do some testing on some advanced setup for your Istio UI, it's a lot easier to just do it locally with Docker and changing the values for Istio. So it generates a pretty cool mesh, and I'll show you. If you go in the example Docker folder in the project, you just need to do a Docker compose up -- build. And so what this is going to do is stand up all of the Istio components, and then also stand up a mock service that kind of feeds Prometheus data that you can visualize. So what you need to see here is the Istio web is compiling. It uses Webpack, so it's a front-end framework. And once that's ready, we should be able to open up Istio locally. And here it comes. And so this is all mock data for my example. And this is for you to play around with. I added a custom label onto my Istio request count metric so that you could display by cluster. So each of these clusters are actually clickable. You can zoom into them and view them. So let's view the mesh in the US West 2 cluster. So this is the generated mesh. It kind of simulates a real-world Istio mesh in certain ways. So I have an Istio ingress controller that's running, and there's traffic coming from the internet. So we can click on this, and we can see how much traffic is coming and how much is going out. And the load actually that I put on it is quite large. It looks like 400,000 requests per second. And the load actually doesn't really affect the flow or the data. But the red you're seeing there is actually 500 errors. So 500 errors will show as red dots. Yellow dots will show as 400 errors, and then blue is 200. So if we want, we can come in here and let's filter down. I don't think my filters are going to work very well. Yeah, so for the demo, here we go. Nope, I guess we're not going to be able to filter. So filter doesn't work in the demo. But there is some alerting that you can do as well. And I don't have this in the demo, but you'll be able to see little pop-ups that will allow you to kind of debug a little bit where your network is going bad. So if you see a red line between two services, you know something bad is happening. You can quickly identify, those services and hopefully fix them. So this is a reskinned UI from the Visceral to kind of match Istio's color palette. So nothing really fancy here, minus I reskinned it. You can also search for, so there's the Ingress Gateway if you need to search for certain components. So a very nice UI. There's some cheap fun you can have with the display. So you can allow dragging of nodes, and you can add some physics. And so just some fun stuff that I don't know if it really has any use, but pretty neat. So that's the Docker Compose demo. If you want to play around with the mesh and try some things out, this is a great way to get into it. All right, so let's stop that. Okay, so let's see if our Istio stuff has come up. And it looks like, so we have a Istio API. It's our API server that feeds this web project, which is the UI, so Istio UI. So it looks like both of them are running. And so to do the demo, we actually have to run kubectl port forward for both of the API and the web. And we can also, should actually note that we should actually, I'm going to generate some load as well. So I'm logged into the rating service, and I have let's see here. I just have a simple curl to call the product page pretty much over and over. So this is just going to generate some load for us, 1 per second. So you'll be able to see some things happening here. So now I'm back. I'm on the Medium page, and I'm actually going to copy the port forward commands. So this one is going to, I think it's going to expose API. Oh, I lost. It's missing all of my. I lost my quotes. That's not fun. Let's see here. So apparently Medium will format your quotes, so be careful. There we go. Okay, so the API server is now up and running at 9091. And so we can go over and check to see that we're actually getting data. So it's a good check to make sure that everything's working well. And so you call localhost 9091 graph. And we got a lot of data listed here, so that's good. That means we're getting data from Prometheus, and that this is going to be fed to the UI for rendering. So let's expose the web as well. There we go. So now the Istio API, this is from my Kubernetes cluster on localhost 8080. Perfect. So we can see that I'm doing, this is total to your mesh. So this example is showing that I have 8 requests per second currently in my mesh total. So from all the connections being made. So we can zoom in and go see here. And so this is the Istio product page demo, or the book info demo. And we have very light amount of traffic going on here, but we can actually see that the dots coming across, those are those requests that I am submitting. And you can view your mesh and your connections very easily. So very simple demo for anyone wanting to get up and running. And then as you build your own mesh, you probably want to tweak these queries to make them a little more sophisticated and tuned to your environment. So this is more of just an example to get your demo up and running to see that it works. And I think that's pretty much it. It's really fun. We're actually going to be using it at the weather company because we have quite a large mesh, and it's going to really help us identify where issues are arising between services. So it's a really quick view to start with to determine where you're having issues. So it's also really fun.